In section 1.3, we talk about powers, square roots, and the order of operations. So the first thing we need to talk about is exponential notation. So if x is a real number and n is a positive integer, then x to the n power is just x times x times x times x n times. So let's go ahead and write an exponential notation. We have negative 2 times negative 2 times negative 2 times negative 2 times negative 2. So because we have 5 negative 2's, we can write this as negative 2 to the 5th. Now make sure you use parentheses when putting the negative 2 in there. What about the second one? We have a bunch of x's. It looks like it's there 1, 2, 3, 4, 5, 6, 7, 8 times. And so that's just going to be x to the 8th. And then we've got negative y times y times y. So this is going to turn out to be negative y cubed. Now the difference between A and C is that the negative and the 2 were both there 5 times. In C, the negative is only out front and the y is there 3 times. So when we raise powers, we have to be very careful of the parentheses with negative numbers. So let's just go the opposite way. Let's evaluate. I'm going to give it to you an exponential, and I want you to tell me what it is. So negative 2 to the 4th, well, that's negative 2 times negative 2 times negative 2 times negative 2. Well, we can multiply negative 2 and negative 2, which is 4, and negative 2 and negative 2, which is also 4, and we get 16. Now we have negative 2 to the 4th. This is like part C in the first example. The negative is out front, and only the 2 happens 4 times. So that's like having the negative out front and then 4 times 4. And so this one gives you negative 16. So although they look similar, they gave us 2 very different numbers. Negative 5 cubed, that negative is inside the parentheses. So that means we've got negative 5 times negative 5 times negative 5. So that's like 25 times negative 5, which is negative 125. And 1/3 cubed. That's like having 1/3 times 1/3 times 1/3. And remember, we multiply across the top and bottom. And so 1 times 1 times 1 gives me 1. And 3 times 3, which is 9, times 3 gives me 27. Now let's talk about finding square roots. So the radical is the actual symbol. What's underneath the symbol is the radicand. And then the square root of 9 gives me 3, and that is the principal square root. So let's go ahead and evaluate. The square root of 81. Well, that's going to be 9, since 9 squared equals 81. So we're looking for something so that when I square it, I get that radicand. The square root of 0 is just 0. Again, since 0 squared is 0. And the negative square root of 49, that's going to give me negative 7. And that's because negative 7 squared is going to give me that negative square root of 49. Let's try some that look a little bit more complicated. So the square root of 0.04, so what squared would give me 0.04? Well, that's actually 0.2. So 0.2 squared gives me 0.04. The square root of 25 over 36. So we can actually split this into two separate radicals. We got the square root of 25 over the square root of 36. Well, the square root of 25 is 5, and the square root of 36 is 6. And the square root of negative 16. Is there a number that when we square it gives me negative 16? There is not. So the difference between the square root of negative 16 and that negative square root of 49 is the negative was inside the radical for this example. And so this is not a real number. Now let's talk about order of operations again with a little bit more difficulty. So we have the same rules. We combine numbers inside the grouping symbols. We raise numbers to their indicated powers and take any indicated roots. We multiply and divide numbers from left to right, and we add and subtract numbers from left to right. So let's look at example number 5. The first thing is to simplify any grouping symbols. So this 4 minus 6 needs to be simplified first. Don't just assume that parentheses mean grouping symbols, because sometimes we use it for multiplication, just like that negative 4 that's in this problem. That indicates multiplication. So let's simplify 4 minus 6 first. That's negative 2 cubed plus 5 times negative 4 plus 3. Well, the next step is to take anything to an indicated power. And so negative 2 cubed is negative 8 plus 5 times negative 4 plus 3. Next thing is multiplication and division. So we have multiplication, we got 5 times negative 4, and that's going to give me negative 20. And then we just want to add and subtract from left to right. So negative 8 minus 20 plus 3, that is going to give me negative 25. Let's do the same thing for example number 6. So we've got 2 plus 66 divided by 11 times 3 plus 2 times the square root of 36. So we don't have any grouping symbols going on here. So the next step would be powers or roots. And we do have a root in this one. We get the square root of 36. So we can simplify that. We've got 2 plus 66 divided by 11 times 3 plus 2, and that's going to become 6. Now we want to do multiplication and division from left to right. So the first thing is 66 divided by 11, and we get 6 times 3 plus 2 times 6. We want to go ahead and do both of our multiplications, 6 times 3 and 2 times 6. And so we get 2 plus 18 plus 12, and that's going to end up giving me 32. And for the last example, we want to do the numerator and the denominator separately, and then see if we can divide and make this a nice number. So looking at the numerator first, we've got 2 times 6 squared minus 12 divided by 3. So we don't have any grouping symbols, but we can raise that 6 squared. So that's 2 times 36 minus 12 divided by 3. And we could do our multiplication and division. So 2 times 36 and negative 12 divided by 3. 2 times 36 is 72. And negative 12 divided by 3 is negative 4, which gives me 68. The denominator is pretty easy to simplify. We got 4 minus 8, which is just negative 4. And so now we want to see if we can simplify. 68 divided by negative 4, one positive and one negative is going to give me a negative number, and 68 over 4 is 17. So our final answer is just negative 17.